Okay, girls, to continue our previous work in period 2, we are going to be continuing the lesson of 19.4 perpendicular lines. And as we begin talking about perpendicular lines, we said that perpendicular lines is when you have two lines that they intersect at a certain point, and at this point, they will be 90 degrees. And then in the first period, we took how can I construct a perpendicular bisector using the compass and using a ruler, if you remember. And we said, what is a perpendicular bisector? Perpendicular bisector means what? Perpendicular bisector is when you, if you remember, this is what we did. When you have these two lines, for example, like this and like this. But this line is very, very special in which, or in that this angle is exactly 90 degrees and the line is exactly dividing this line into two equal parts. So in this case, it's going to be called a perpendicular bisector. So this line is a perpendicular bisector of this segment. Okay, okay. And then we have to complete our lesson. So let's go back to, we finished this page and we were in explain 1 in page 966. Please try to focus with me very, 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 very much. It's very easy lesson, but it's very easy for you to get lost. So please try to concentrate. This lesson is going to be divided into 3 parts, 3 explanations. The only hard thing in this lesson is the proofs. But the lesson actually as a theorem, when you are solving with the theorems, it's very, very, very easy, very easy. The theorems itself to use so that you can solve the question, it's very easy. The only little bit hard thing is the proof questions that we are going to be making. So just please try to concentrate. Okay, we are going to be taking 3 explanations. Explain 1 is proving the perpendicular bisector theorem using reflections. And then we are going to be taking proving the converse of the perpendicular bisector theorem. You remember before, you have to take the theorem and its converse. You have to take the theorem and its converse. And then for explain 3, we are proving some theorems about right angles. So going back to explain 1. What is this theorem talking about? Perpendicular bisector theorem. Girls, you don't need to like memorize the theorem, no, but you have to understand it carefully and understand it very, very, very well and actually know the name. You have to know the name so that when I ask you, a perpendicular bisector theorem states that, you have to know it states what. You don't need to say every part in details, just express the theorem in your own words and you have to understand and you have to link between the name and the statement. So the perpendicular bisector theorem states what? Can you see this segment in here? We have a line segment in here. We have AB, right? And then we have this line M, and it's considered that this line M here is a perpendicular bisector of AB. So we understood, since it's a perpendicular bisector, so this angle is 90, this angle is 90, and since it's a bisector, so this part is exactly equal to this part, right? Okay. Can you see this point P? This point P is any point lying on this line. P is a point lying on this line. So what will happen? The perpendicular bisector theorem is talking about, what if we draw a line from P to A and draw a line from P to B? If a point is on the perpendicular bisector of a segment, like this point P in here, it's on M, which is a perpendicular bisector of AB, then it is equidistant from the endpoints of the segment. Then it is what? It is equidistant from the endpoints of the segments. What does this mean? We need to understand very, very, very carefully. No, let's draw. Equidistant means what? What if I draw a line from here? I'm so sorry that my hand is a little bit shaky. Yeah. Try to think that it's a very, let's do it in here. It's a very, very, very smooth line. Yes, from here to here. And a very, very smooth line from here to here. The perpendicular bisector theorem is saying what? When you have a point which is lying on this line M, it will be equidistant from the endpoints of the segment. This segment, how many endpoints does it have? It do have endpoints. It have two endpoints. It have A and it have B. If you connect this point to A, and if you connect this point to B, you will find that this distance is exactly equal to this distance. This is your theorem. This is your theorem. You will find that this distance is exactly equal to this distance. This is your theorem. So again, the theorem is saying what? When I have a line segment and there is a perpendicular bisector, so that this is equal to this. And if I have a point which is on this line segment, if I connect these two lines, they will be equal. They will be equal. Okay, this is what is meant by equidistant. Equi means equal. Distant means distance. Equidistant from the endpoints, yani the distance from the point to the end point here and the end point here, and they are equal. Very good, very well. So just to understand what happened first. What happened first was that I had a perpendicular bisector and the point P was on this perpendicular bisector. Then what happened? PA was exactly equal to PB. You understand? Because we are going to be taking the converse, so you have to understand how many events are happening here. Two events are happening. Event number one is the perpendicular bisector. Yani that there was a perpendicular bisector. Then what happened? It was equidistance. Okay? Okay. The thing which I'm talking about hard, it's not like hard, it's just that try to broaden your mind. We are going to be proving the perpendicular bisector theorem. You remember in the first period I told you what is the main difference between a postulate and a theorem. A postulate is a statement which is always true, you don't need to prove it, right? But for a theorem, whenever we will be having a theorem, we will always be having its proof. A theorem is correct, but after you prove it, you have to prove why is it correct. So this is what we are going to be doing. We are going to be proving the perpendicular bisector theorem. What is my given? My given is that point P is on the perpendicular bisector of AB. So this is the first event that happened. You remember? This is the first event that happened, which is I have a perpendicular bisector and point P is on it. What will happen, or what we need to prove, is that PA is exactly equal to PB. Actually, to prove this kind of a theorem, there is many ways. But your book chose to do this proof using reflections. But actually, when you are doing the homeworks, I think maybe tomorrow or something, we will be having another ways to prove this theorem using our statement and reasons. It will be much easier. But let's use the book's way using reflections. You remember reflections? We remember reflections, right? You remember when we had a line and we needed to reflect a point. What should I do to reflect this point? I will bring my ruler and put it in here, and then I will measure this distance and copy it to the other side, and then I will say, yes, so this is the reflection of my point, in which, so that this distance will be exactly equal to this distance. We said if this is 2, so this is 2, and so on. You remember? Okay. In here, to prove this, of course, this is like a paragraph proof. Consider the reflection across. What is my line of reflection here? We are considering that the line of reflection here is M. So consider the reflection to be across line M. Okay, it will be across line M. It will be across line M. Okay, you remember we said when I have a point which lies on the line of reflection exactly, its reflection will be what? Will be as it is. You remember when I told you, try to stick your finger on the mirror. Its reflection will be what? Will be on the same point. right? And as you go further from the mirror, your reflection is going further away. But if you are like point P in here, the reflection of point P across M will be what? Will be here, here, there, here? No, it will be the same point, right? So then the reflection of point P across line M is also P. It will be the same point, right? Why? Because point P lies on the line. Here we are going just to write on the line. Or on M. On the line. Of course, I want to make it smaller, but I will not be able, I think. Yes, on the line. Yes. So on the line, which is, or on line M. Let's write here on line M. It's better on line M because we have many lines in here. So on line M, okay? It's better. يبقى till now, consider the reflection across M. Then the reflection of point P is the same, is also P, because point P lies on line M, which is the line of reflection. Okay. Let's reflect A. Also, the reflection of, you remember that the distance from A to the line is the same as the distance from the line to B. Yani, as if we can consider that actually the reflection of A is B, because it is the same distance. It is the same explanation I just explained in here. When you are reflecting, the reflection should be equidistant, right? So since this is equal to this, we can consider that the reflection of point A is actually point what? Actually point B. So this is what we are going to write in here. Also, the reflection of here, it's going to be also the reflection of A will be across line M is B by the definition of what? By the definition of reflection. By the definition of reflection. So point P, its reflection is the same. And here the reflection of A is B. So since point P is the same and the reflection of A is B, so we can say that PA is equal to PB because what? Reflection preserves distance. You remember, reflection is a rigid or non-rigid motion. Reflection is a rigid motion, right? When you did a reflection, your triangles or your quadrilateral or your figures, did it change size? Never, right? Consider that you have this triangle here. I have this triangle. We have P and then this point and then A. This triangle have a certain length, right? If this length is the same in here and this length is the same in here, this length should be what? Should be the same, because if it's not the same, this reflection is non-rigid motion, right? So since reflection is a rigid motion, so PA should be equal to PB because reflection do what? Because reflection preserve length. Because reflection preserve length. Just in here, okay? So this is our proof. So what did we do? We used the reflection. We used the definition of reflection so that I can prove this theorem. As I told you, it can be done in many ways, but this was the book choice, is to use the reflection that is already fresh in our mind to prove it. As we said, because reflection is a rigid motion, it preserves length, it preserves size. So since P is the same, A and B are the same, so this distance should be the same, otherwise the size will change, right? Okay, very good. Let's go back to our page in here. Sorry, everything will be moving. I hope you took all, because I have to remove all of this. Okay. So let's go to the reflect question. What conclusion, can you see what's happening here? We have a segment, we have line segment KL, And then we have point or line JM. We have a point JM in here, and with the graph, with the figure, he didn't tell me anything. You have to be careful how to use your eyes. Not everything, girls, should be written in the question. And do not tell me, teacher, he didn't say whatever. You have to use your eyes and see what's happening. Using my eyes, I found that this angle is 90. And I found that these two parts are equal. So I know that JM is the what? Is the perpendicular bisector of JL. Did he tell me anything? Actually, he didn't. He didn't tell you anything. This is all with my eyes, because this is going to be happening in all questions. Actually, he's not going to give you anything. He's just going to give you the figure, and you have to find everything from the figure. So this is what I did. I found that this angle is 90. These two parts are equal. So this is the perpendicular bisector of KL. Since it is the perpendicular bisector, using the perpendicular bisector theorem, I can say what? That JK is equal to JL. Right? So this is what we are going to be writing in here. Very good. This is what we are going to be writing in here. So draw, what conclusion can you make about triangle KLJ in the diagram using the perpendicular bisector? I found what, since this is equal and this is a perpendicular bisector, we found that KL should be equal to JL. Okay, understood? Understood? Okay, very good. Let's go to the second page. Okay, I will do with you your turn just to make sure that you understood what do I mean by using your eyes. I will do with you question 4 and 5. Use the diagram shown. BD is perpendicular. Actually, he told you here. BD is the perpendicular bisector of AC. So I understood that this angle is 90, this is 90, and that AE should be equal to EC, right? The question is, suppose that ED in here is 16 centimeter. DA, this side in here, is 20 centimeter. Find DC. Using the perpendicular bisector theorem, since this is equal to this and this is a perpendicular bisector, so DA will be equal to DC. So DC will be equal to what, girls? It will be equal to 20 centimeter. Exactly. Very good. So in here, I'm going to tell him, just let's make it a little bit bigger. So what I'm going to tell him, using perpendicular bisector, DC will be equal to DA will be equal to 20 centimeter. Okay, question 5. Suppose that EC was 15 centimeter. In here, this is 15, and BA is 25. Find BC. Again, very easy, very easy. BA is 25. Using the perpendicular bisector theorem, BA should be equal to BC, because this is what we said in the perpendicular theorem, that this point should be equidistant from the two endpoints. And the two endpoints, one is A and the other is C. So BA should be equal to BC. So again, this is what we are going to be writing in here. BA is equal to BC equal to 25 centimeter. Equal to 25 centimeter. Very easy, right? Very easy. This is the lesson. Very, very easy lesson. Okay. I will clear. And then let's take our second explain. Explain 2. As I told you, explain 1 was proving the theorem. What was the theorem again? What was the theorem again? The theorem again was talking about, if I want to just like write, because it's very important, as we said, for you to understand a theorem and its inverse. So the perpendicular theorem was saying, if P is on the perpendicular bisector so it is equidistant from the end points. What I am trying to do the converse now. The converse will be the opposite. In here, girls, in here, these are my two events. The first event is if P is on the perpendicular bisector. This is the first event. The second event, so it is equidistant from the end points. This is my second event. So to do the converse, what will happen? I'm just going to swap 1 and 2 together. I'm going to swap 1 and 2 together. Let's swap them. If P is equidistant, this is what happened first. If it is equidistant from the two end points of a segment, then it is on the perpendicular bisector. It's very, very important for you to understand how to write a theorem and then how to write its converse. Very, very important. And we can say that, again, as if we have here this triangle. This is a very, very, very bad shape. So let's go to our book. It's better to use our book. It's already drawn for us. Let's use it. Okay, before we read, let's just see the figure. Consider here that yes, in here, the converse of the perpendicular theorem will be, he will not tell you that this is 90 and that these two sides are equal. No, actually, he will tell you that these two sides are equal. And when you know that these two sides are equal, so you will understand that JM will be the perpendicular bisector of KL. You understood? So it will be the opposite. Instead of telling you that these two sides are equal and that this angle is 90, no, he will tell you if these two sides are equal, so JM is the perpendicular bisector of KL. Okay, let's see. The converse of the perpendicular bisector theorem is also true. In order to prove the converse, as we said, it's a theorem, so we have to prove it. We are going to be using something called an indirect proof and the Pythagorean theorem. Forget about the thingy of the indirect proof. We are going to be using the Pythagorean theorem. What is a Pythagorean theorem? Let's from here read. If you remember, the Pythagorean theorem was talking about if I have a right angle triangle. You remember the right angle triangle? When I have a right angle triangle is a triangle in which this angle is 90 degrees. You know that any triangle have three sides. We always named the hypotenuse. The hypotenuse is the side in front of the 90 degree. The hypotenuse is the side in front of the 90 degree. It can never be this, it can never be this. It's always this. This is the hypotenuse. We always named it C, and then one of this was A and the other was B. The Pythagorean theorem told me that A square plus B square will be equal to C square. This was the Pythagorean theorem. We took this in grade 8. So the Pythagorean theorem stated that if I have a right angle triangle, so A square plus B square will be equal to the hypotenuse square, which is C square. We are going to be using this to prove the converse of the perpendicular theorem. Let's read the converse of the perpendicular theorem. If a point is equidistant from the end points of a segment, as I told you, if this was equal to this, then what will happen? It lies on the perpendicular bisector of the segment. And you will understand that actually this line will be the perpendicular bisector. And you will understand two things, that this angle is 90 and that these two parts are equal. Understood? Okay. Again, we need to do what? We need to do the proof. We are going to be proving again using a paragraph proof. It's very important for you when he is asking about a proof to use the proof stated in the question. If he didn't tell you, like in this question, just he is telling you to prove, you can use your own way, whatever you want. Paragraph, it's okay. You can use the table method, it's okay. But if it's stated in the question to use whatever method, you have to use it, because some of you sent me homework questions done in a different way. No, you have to use the way which is stated in the question, please. Okay, the given here is that PA is equal to PB, and you are required to tell me or to prove that P is on the perpendicular bisector. Yani in other words, you have to tell me that, I will have to prove that PQ is the perpendicular bisector of AB, that this angle is 90 and that these two sides are equal. Okay? Okay. In the beginning, the word indirect proof is indirect proof, just to understand it, means that you are going to prove in an indirect way. Direct is the direct way, indirect is that as if you are contradicting yourself. We are going to be saying that in the beginning, P was not on, yeah, we are going to contradict ourselves. First of all, let's say that point P was not on the perpendicular bisector. And then we will work our way through until we can prove that actually, no, PQ is on the perpendicular bisector. Anyway, don't bother yourself with the word indirect proof. I'm going to tell you how to use it. Okay, let's say that these two, this big triangle, which is APB, was divided into two parts, two triangles. Can you see these two triangles? In these two triangles, this angle was 90 and this angle was 90. Since this angle was 90 and this angle was 90, I can use the what? I can use the Pythagorean theorem, right? Okay, I will start from step B, girls. Okay, I'm not going to do step A, starting from step B, because step A is about the indirect proof. And just starting from step B is easier. Okay, let's do it together and read and complete together. Okay, complete the following to show that this assumption leads to a contradiction. PQ forms two right-angled triangles, right? Triangle AQP and triangle what? PQB, right? This is the first triangle. So here, I'm not going to be able to do the triangle mark. You have to do it. I'm just going to name the triangle. The triangle is PQB. This is my triangle, right? Very well. So, using the Pythagorean theorem in here, where is for the first part in here, where is my hypotenuse? This is the 90 degree, so the hypotenuse will be AP, right? So we can say that, or PA, by AP is the same as PA. So PA square will be equal to AQ square plus PQ square, because we said that C square is equal to A square plus B square. This is what he wrote in here. AQ square, which is A square, plus PQ square, which is B square, is equal to C square, which is PA square. Let's do the other part. In the other triangle, where is C? PB is C. PB is C, because it is the one in front of the hypotenuse. So let's write the rule. So PQ square plus QB square is equal to, what should I write in here? PB square. PB square, right? PB, and you have to write the square up, please. You have to write the square up here. This squaring thingy should be in here. I'm going to make it like power 2. But you please do it PB square. You do it PB square. By the what? What should I write in here? By the what? By the Pythagorean theorem. In here, you are going to write, I'm going to just write it down because it's a very long word. Pythagorean theorem. Using the Pythagorean theorem. Very well. Now, girls, we have two equations. AQ plus QP square equal PA, and PQ square plus QP square equal PB square. Remember that the given was PA is actually equal to what? PB. PA is actually equal to what? PB. This was given, right? And remember that PQ is one side used in both triangles, right? Okay. Based on this, we have these two equations. We are going to do a subtraction. Let's subtract these two equations together. I'm going to put this one first and then the second one down, and then let's do subtraction. As if here we are doing a subtraction. Let's do a subtraction here. This is minus, and this is minus. Let's do the subtraction. First of all, AQ square minus BQ square equal QP minus QP. What will happen? Elimination. They will cancel each other. Equal to PA square minus PB square. Right? Right. But we already was given that PA is actually equal to what? Equal to PB. Since they are equal, يبقى PA square minus PB square will be what? Will be 0. Right? Because PA is actually equal to PB. Since they are equal, but if I subtract them together, they will be 0. So since this became a 0, as if this became a 0 here, therefore AQ square minus BQ square became equal 0. How can a subtraction be equal 0? AQ square minus BQ square equals 0. If I shift the BQ to the other side, what will happen? The AQ square will be equal to BQ square. And if I use a square root in here and square root in here, what will happen? I will end with that AQ is actually equal to BQ. AQ, this part in here, is actually equal to QB. Don't mind the drawing, girls, as if it's already was equal. So AQ was already equal to BQ, right? So B must lie on, what should I write in here? Here I'm going to write, since that AQ was equal to QB and that PQ was 90 degrees, so we can write that P is on the perpendicular bisector of AB. So PQ is on the perpendicular bisector of AB. But again, what did I do in here? I subtracted the two equations. Elimination happened, and then this was equal to this. This part became 0 because actually these two parts together are equal. They are equal. So what will happen? As if you are doing 2 square minus 2 square, 4 square minus 4 square, it will be 0. So this part became equal 0. So actually, it means that these two parts are equal. Since these two parts are equal, and this is 90 degrees, so we can say that PQ is the perpendicular bisector of AB. So in here, girls, you are going to write P lie on, and we are going to write perpendicular bisector. Perpendicular bisector of AB. This is how we proved it. So we proved our question. It's okay? Understood? Okay. I'm going to remove. Done. Okay, clear all drawings, and then yeah, let's go to the second page. Your turn. You are required to try to do your turn by yourself. Question 7. I'm just going to read it with you. He gave you that AD is 10. And you know what does this mean, girls, right? When he give you this thingy, he means that these two sides are equal. When he tells you that this is like a mark and this is like a mark, so he means that AD is equal to DC. So you understand that this is 10 and this is 10 as well. And he gave you BD equal to 6. He gave you BD equal to 6. Since you understand that this is, he already gave you that this is 90 degrees and this is equal to this, so I can say that BD is the perpendicular bisector of AC. So this part will be equal to this part, right? For now, I understand that this part is going to be equal to this part. I understand this. The question is, how can I find AC all? I can't find AC all, but if I find BC only, I'm going to multiply it by 2, and then I will find AC as a whole, right? So how can I find BC? Remember that BD is 6, it was given, and that this is 10, it was given, and that this is a right angle triangle. So how can I find this using the what? Using the Pythagorean theorem, right? Using the Pythagorean theorem. Yani you are going to say that A square plus B square equals C square. Yani 6 square plus B square, which is unknown, is equal to 10 square, which is 100. And then what should I do? B is unknown. I have to find the answer here and then shift it to the other way to find B. I already solved it for you, but you just have to complete it and find the answer. After finding B, which is BC, is BC enough for me? No, I have to find and do the same thing for AB, or just multiply BC by 2 because they are already what? They are already. Okay. The last part of our lesson, will be explain 3, which is proving theorems about right angles. We have 2 theorems in here, and this time he is using the proof of the table thing. First of all, you know this symbol, right? The symbol, this means that 2 figures are perpendicular. Yani when he tells you that L is this thingy, M, he means that L is perpendicular to M. Remember, girls, when he gave you this L, and then he did this, and then M. This means that L is parallel to M. When he tells you that L is this thing, he means that L is perpendicular to M. Because take care, this is going to be used heavily in the next lesson. So you have to differentiate between the parallel sign and the perpendicular sign. And perpendicular, I understand that it means that the angle is 90, right? Okay. The first theorem that we need to prove each theorem about right angle. If 2 lines intersect to form one right angle, and he is telling you here, if I have these 2 lines and these two lines intersect to form one right angle, and if it was given that this angle, measure angle 1, is 90 degrees, then what will happen? Then actually angle 2 is going to be 90, angle 3 is going to be 90, and angle 4 is going to be 90 without he say anything. Again, if he give you this figure, if he just give you 2 intersecting lines, they intersect in a point, and then he just did this in the figure, you understood that this angle is 90, right? Do not go in the exam and ask yourself, he didn't tell me what is this angle and what is this and what is this, how can I solve it? It's already known that since this is 90, so this will be 90, this will be 90, and this will be 90. All of the angles will be 90 degrees. We are going to prove why is this happening. Given that measure angle 1 is 90, we need to prove that measure angle 2 is 90, 3 is 90, and 4 is 90. Actually, there is a lot of ways to prove this theorem. I'm going to explain with you the book way, but actually there is a lot of things you can use. So first of all, as we said before, statements and reason, we have to write our givens first. Measure angle 1 is 90, this is a given. And then angle 1 and angle 2, girls, angle 1 and angle 2 are actually what? They form a linear pair, right? Angle 1 and angle 2 are a linear pair. Why did he write given here? Because it's given from the drawing. It's already given inside the drawing, right? So this is given. Since they are linear pair, but we can say that they are supplementary, right? This is the definition of, or this is the linear pair theorem. This is the linear pair theorem. Since they are supplementary, it means that if I add them, they will give me what? They will give me 180 degrees, because this is the definition of supplementary angles. Okay, let's substitute. He told me that measure angle 1 equal 90, right? Let's substitute it in here. So 90 plus measure angle 2 will be 180 using the substitution property of equality. And then let's shift 90 to the other side by the subtraction property of equality. 180 minus 90 will be 90. So we proved that measure angle 2 is 90 degrees using the what? Using the subtraction property of equality. So let's go to the figure. Angle 2 and angle 4, they are what together, girls? Angle 2 and angle 4, they are what? They are, can you see the X? We have an X here. So they are what? They are vertically opposite angle, right? Since they are vertically opposite angle, so they are what? So they are equal. And equal means, not equal means, equal because what? Because of the vertically angle theorem, vertical angle theorem. So what this is what he did in here. Measure angle 2 will be equal to measure angle 4. Why? Because of the vertical angle theorem. Because of the vertical angle theorem. Yet till now, 1 was given to be 90. We proved that 2 is 90, and we proved that 4 is 90. I still have 3. Again, 3 and 1 are what together? We have again another giant X in here, right? So 1 and 3 are what together? 1 and 3 are again vertically opposite angle. So we can say in here that measure angle 1 will be equal to measure angle 3 because of the vertical angle theorem. Yani it means that measure angle 3 is 90 using the substitution property. The substitution property of equality in here, it means that he substituted, since they are equal, so we substituted the 90 to be for measure angle 4 and the 90 to be for measure angle 3. And you are done. We proved that if one angle is 90, so the other 3 angles will always be what? Will always be 90. So please, girls, if this come in the exam, if this come in the homework, if this come in the online assignment, it's very, very important for you to understand that he didn't, or he don't need to give you all the angles. One angle for you is enough. If it's 90, so all of the other angles are 90. If it wasn't 90, this is another thing. He should give you the angles. But if they are perpendicular, so all of the angles are 90. Okay. Let's go to the last page. Actually, you are in the same page. Question B. If two intersecting lines form a linear pair of angles with equal measures, then the lines are perpendicular. What is this? This time he is telling you if line L and line M, again, they are intersecting each other. As you can see, 1 and 2 are what? Linear pair. It's very obvious that they form a line. If he tells you that measure angle 1 is equal to measure angle 2, and you understand that they are linear pair. Girls, linear pair means what? That they are supplementary, right? Yani angle 1 plus angle 2 should be 180. If they are equal, if you are given that angle 1 is actually equal to angle 2, what plus itself will give you a 180? What plus itself will give you a 180? 90, right? 90 plus 90 will be 180. So if you are given that measure angle 1 is equal to measure angle 2, and that this form a linear pair, so you can know right away that angle 1 will be equal to angle 2 equal to 90, or we can write that L will be perpendicular to M. L perpendicular to M means what? That this angle is 90 and this angle is 90. We need to prove it, but this time we are going to prove it using the paragraph method. Yalla, let's do it together. By the diagram, angle 1 and angle 2 form a linear pair. So angle 1 and angle 2 are supplementary by the what? Linear pair theorem, right? This is what we are going to be writing here. This is the linear pair theorem. Linear pair theorem. Okay, so by the linear pair theorem, by the definition of supplementary angles, measure angle 1 plus measure angle 2 should be what, girls? Should be what? Should be 180. Exactly. It should be exactly 180 degrees. It is also given that what is given? That measure angle 1 is equal to measure angle 2. So this is what we are going to write in here. that it's given that measure angle 1 is equal to measure angle 2. This should be yes, this is better. Okay, so measure angle 1 is equal to measure angle 2. So measure angle 1 plus measure angle 1 is 180. What did he do here? He substituted, he removed measure angle 2 and put measure angle 1 instead, because they are already what? Equal. So by the what? By the what? By the substitution property of equality, right? By the substitution property of equality. So let's add them together. So twice measure angle 1 will be 180. Divide by 2, divide by 2. So measure angle 1 will be 90 degrees by the division property of equality. Therefore, angle 1 is right angle and M and L is perpendicular to M by the perpendicular theorem. By the perpendicular theorem. Let's make sure, is it by the perpendicular? Yes, by the definition of perpendicular lines. Just by the definition of the perpendicular lines. So in here, just you are going to write by the definition of perpendicular lines. So in here, just we are going to write by the definition of perpendicular lines. Okay, understood? So again, whenever you have a linear pair in front of you and just you understand, or he tells you that angle 1 is equal to angle 2, you will already know, since they are equal, so this is 90 and this is 90. Okay? Okay. And then the last thing which is required from you, I'm going to leave this question for you. Given that B and D are parallel, C and E are parallel, you are given some angles and you are required to find some angles. This is going to be like a homework for you. And girls, please, to take your attendance today, attendance are not going to be taken just by seeing the video. You have to send me our work, otherwise you will be considered as absent. So please, after seeing the video, even if you couldn't finish all, you can finish 1 or 2 or 3 questions. You can finish even the classwork that we did and then send me a picture or put it on your portfolio, and then you will be marked as attending. Please, otherwise it will be, yeah, just seeing the video is not enough. Okay? Okay, thank you very, very much. And for your homework, it will be written on the post of Class Dojo. Thank you and see you tomorrow, inshallah.